afternoon, everybody, and welcome here to the Science Gallery. I'm delighted to see you all. We have two schools here today. You don't know each other, I'm sure. So it's CLARITY in Lucan, and sorry, I was going to say the gentlemen from CLARITY in Lucan, and a lady who's well able to handle them, I'm sure, is Agnes Hackett. So thanks, Agnes, for bringing them out today, and I'm sure they'll be on their... I'm sure they'll be on their best behaviour. Also here today we have ladies and gentlemen from Old Bald Community School. Okay, guys, it's not a competition today, but and the teacher travelling with them today is Edel McGovern. So welcome, Edel. Okay. My job today is just basically to introduce the speakers, but also to tell you a little bit about Discover Science and Engineering, which is the body that I work for. Discover Science and Engineering it's a government-funded awareness program to promote science, technology, engineering and maths, both to students and to the general public. In terms of the general public, and indeed students, we run Science Week, and this week there's over 400 events happening all around the country. You can find out about any more of those events if you want to log on to the scienceweek.ie website, and there's a very good search engine in there as well to search for any events in your area. There's loads of them going on. As I said, over 400 happening right around the country. Also, on a general note, we promote science careers, and we also have a website there called mysciencecareer.ie. So if you want to have a look at that in your spare time, that'd be great as well. We also take part in the Young Scientist competition. We're a gold partner with Young Scientist, and we'll have a huge stand there, and we hope we'll see you all there in January. Our theme this year is the science of sport. I do know we're going to have a Formula 1 car there this year, so please come to our stand and support us at the Young Scientist. There's been loads of other stuff demonstrating how science is used in sport there. On the education side, and this is where I work, we have two major projects. One is called Discover Primary Science. That's well up and running now for a number of years, and we're working with over 3,000 primary schools in the country with that project. So that's over 3,000 out of 3,300 schools, so we're thrilled with that. The projects that we do on secondary school levels, there's two of them. One is called Discover Sensors, and incorporated into that then is Project Blogger, where we actually get kids and teachers to use a blogging tool to blog experiments and projects. So we're working with Young Scientists this year, and we're getting some of the students who are entering the Young Scientists to work with us and to actually blog about their projects and how they're getting on with their projects. And the same thing with the SciFest next May. So that's Project Blogger. The project then that I'm responsible for is Discover Sensors, and I suppose that's where we link up today with Cian here. Discover Sensors, we're now working with 200 junior certificate teachers this year, and basically what we're doing is working with your teachers using sensor technology to promote inquiry-based teaching and learning. I know that sounds very highfalutin, but you've all heard, I'm sure, the government and politicians in general talking about higher order thinking, about a knowledge-based economy, and all this highfalutin stuff. Basically, what we're trying to do is to work with junior certificate science teachers who in turn will work with you, so that rather than just learning your science stuff off by heart and writing it out, that you'll actually learn how to think, how to ask really important questions. So basically, instead of learning everything, now I know there's a certain amount of stuff you actually have to learn, but instead of learning everything by rote, you learn how to find out about things. You learn how to ask questions. You learn where to go to find out about things. Basically, what you're doing is learning how to think, and that feeds into what the government want in our higher level thinking and knowledge-based economy. So that's enough about Discover Science and Technology. Discover Science and Engineering. I want to introduce now Dr. Cian O Mathúna from CLARITY. He's one of the 6 principal investigators in CLARITY, but he tells me he's the most important one. I don't know if that's true or not. CLARITY is a Science Foundation funded Centre for Science, Engineering and Technology, and it's a partnership between UCD, DCU and the Tyndall Institute. But Cian is actually based at the Tyndall Institute. Indeed, he's the head of Microsystems Centre there. And what he's going to talk about today is, his talk is titled Sensing the Future. So basically, he's going to talk about how wireless sensor networks are set to play a major role in addressing some of the key challenges faced in society, in healthcare, in the environment, and in the energy in our buildings. So what I'm hoping is that today we'll hear about how science, technology, engineering, and maths research, so how the science research is actually being used in real-life situations. So I'm going to hand over to Cian now.
Thank you. Thank you very much. I'm delighted to be here. I hope you can understand my accent. I was practicing my Dublin and it didn't work. The guys, they were going to do subtitles, but we decided it wasn't necessary. Hands up who's been in Cork. Nice one. It's all out now. So Cork is really the capital of Ireland, as everyone is aware. So the Tyndall National Institute, we actually had an opening last week of a €50 million building, which is going to dramatically expand the work that we can do, and is very important in terms of, the current economic situation in Ireland. A lot of you people are going to be wondering, well, where am I going to get jobs in the future? Well, 5 years ago, I guess your mothers and fathers would have said, go into the bank. And actually, it might be a good idea to go into the bank now because we're supporting all the banks. However, I think we can add more value by getting involved in science and engineering that can impact on some of the very significant problems that are facing mankind in the future. The environment, health, and also the whole energy question. So I'm going to talk you through some of that. In Tyndall, we have 370 researchers, engineers, scientists. We have 100 graduate students. We have people from all over the country coming to work in Tyndall. It's a national institute. We work on the hardware side of electronics, optoelectronics, and so on. So on the photonics side, we're interested in how do you get fiber to the home, optical fiber, so that you can actually automatically download movies on demand. I guess most parents would think that would be a really stupid use of technology. Also, looking at nanotechnology, we're trying to develop technology that you won't be able to see, but will have dramatic impact on how we live our lives in the future. I guess you all know who John Tyndall was. Now, there will be an exam at the end of this, so listen up. In any case, it's important. John Tyndall, he was a very important scientist, physicist. Some of you may have done some work in the chemistry lab with Bunsen burners, right? Yeah. So John Tyndall was, I think, the second PhD student of Professor Bunsen in Heidelberg in Germany. He also took over from Michael Faraday as director of the Royal Institute in London. So he is a very important person. He has done a lot of work in the area of medical technology, in the area of optics, photonics, and he explained why the sky was blue. Now, actually, last year when we had the Clarity Open Day, we went to this place, Loughlin Bridge in County Carlow. The sky is not blue in County Carlow. So I reckon that's why he went to Germany, to try and understand. Now, the mission for Tyndall, and this is important, right, because what we are doing is we are spending taxpayers' money. And many of the people in the government are under a lot of pressure at the moment as to how that money should be spent. Some people are saying actually it should be spent in hospitals, in healthcare. There's a lot of children who need better care. There's a lot of people who have to go outside the country in order to get proper care and attention. It should be spent on the road infrastructure. It should be spent on the banks. But that's why it's so important for us to be able to account for the work that we are doing in science and engineering technology and deliver value back to Ireland. So that is a critical element of what we are doing, working with industry in order to create new jobs, the jobs of the future. hopefully that many of you will work in. So I'll just take you to a book that was written in 2000 by a gentleman, Mikio Kaku. And he is not from Cork. Now, he wished to talk about the invisible computer. And I mean, he makes a startling statement. He says that microprocessors in the future will be as cheap as scrap paper and just as plentiful. So basically, we will not be paying any money for silicon chips, which is pretty surprising. But on the other hand, if you think of, how many of you have mobile phones? What a country. Now, what you will find is, increasingly you're paying very little for your mobile phone. You're probably, paying maybe 30 euros or less. In fact, it's your parents are buying it, so you're not paying anything. But the thing about this is that what you are paying for is the services associated with it. But this technology, the amount of technology in this is very, very significant. One of my friends, he went into one of the DIY stores recently, and he wanted to buy a DVD player. The DVD player that he spotted, it was 30 euros. And the lady came along to help him, pick out the unit, and she said, would you like some shelves in order to put the DVD player on? He says, yeah, that would be nice. And she said, well, here's a box kit, you can make it up yourself. Okay, great, how much is that? That's 100 euro. So the wood cost 100 euro, and the technology to watch the DVDs was 30 euro. That's frightening. And that is saying that in the future, the electronics will cost nothing, but the services around it will actually be where all the value will be. Now, in Tyndall, in the area that I'm working in, we are looking at developing technologies around sensors that will impact on energy, the environment, and health. So, first of all, what are sensors? And do we have sensors in the world today? Yes, we do. So, if you think of car alarms, if you think of house alarms, if you think of video systems for security in streets, if you think of home appliances where you can actually monitor the temperature, a kettle has a temperature sensor in it in order to turn it off when the water is boiling. So there are a lot of sensors around our environment at the moment. However, they're not connected to anything. They're what I would describe as dumb sensors. And what we're interested in doing is making these intelligent and eventually connecting them up to the web so that they can make intelligent decisions about what they can do, and they can support society, people, in terms of improving their health, the quality of their lives, their environment, and so on. So if you look here at a technical slide as to what sensors would be, then we can describe the sensors that will detect light, sound, pressure, chemical species, temperature, and so on, that would feed into the electronics that will convert the data from an analog signal to a digital signal, and then it will have to make some decision about what it should do. Will it turn on a light? Will it turn off a light? Will it turn on a tap? Will it turn off a pump or something like that? And all of these will be communicating with each other as well. So in the future, there will be billions of these throughout our environment. Now, what we're trying to do is we're trying to make these invisible. We want them to interface to the physical world. We want to embed intelligence in them, so we get smart sensors. They need to be as small as possible so they can be embedded into the environment, whether it's into our clothing, in buildings, in the external environment, even inside in our bodies. They should be able to communicate wirelessly, and they'll be networked together into very large, what are called ad hoc networks. And they will also be self-powered, so we won't need batteries for them in the future. We will be able to harvest energy from the environment, whether it's from light, vibration, movement, and so on. So here are some examples of the sort of sensors that we're talking about, these intelligent sensors. We have built these so that many researchers can actually work on them. They're very Lego-like, so you can put them together as you would think fit. So they're a bit like maybe the Lego Mindstorms, perhaps. And we would have about maybe 20, 25 different versions of these that you can put together as you want to do whatever experiment you want, whether it's measuring building energy out in the environment, measuring external environmental conditions, and so on. It's a very suitable tool, actually, even for schools in terms of, say, the Young Scientists or Transition Year type programs, so very suitable for the Discover Science and Engineering program. But what we're interested in doing is trying to make those entities as small as possible. So you can see, could we actually get them small enough that they could fit in a syringe and actually get injected into the body? I should say that no animals were harmed in the making of this particular slide. Now, the other thing that we're interested in doing is if we go a step further, and could we actually embed all of these sensors into a credit card? So we make, or into a smart card. So we put all the electronics into a smart card. So we end up with a wireless sensor smart card that can have, instead of just having a chip in it that will give you money, it also has your ID, it has your medical records, but it also could be used in an environment like this to monitor temperature, humidity, and so on. It could be used to monitor your security if you're away from home and so on. So this is what we're trying to do. So we're trying to make the electronics disappear. Here are some examples of, let's say, real-world ideas in terms of energy harvesting from the environment. You can see a hat on the left there, where there's a solar cell on top of the hat for someone who wants to cool themselves down while walking. Now, I guess my kids, my daughter in particular, she likes me to watch Powerpuff Girls with her. And I was a closet fan of the Spice Girls. But I think the power purse is taking girl power to the fair. But here you have a purse. What do you call them? Handbags? Handbags. With solar cells on them. Now, this idea of energy harvesting, let's say if we talk about a building like this here, okay, we've got light from the lights here. We may have radiators that will have a temperature, so we can use the temperature difference using the thermoelectric effect in order to get energy that can be converted to electricity to drive these sensors. In another case, we're using vibrations from pumps and motors in the air conditioning systems to actually drive the various sensors we're talking about. So let's get into look at some of the applications. Just to put a context around applications for energy, right? Worldwide energy usage. 27% of energy is used in transportation, 16% in residential houses, 8% commercial, and 49% in industrial factories and so on. If you just take the residential sector and look at it, 38% is made up of electricity and the rest in combustibles, whether that's gas or oil. And if you look there, 49% space heating, 16% water heating. That's an incredible amount of energy. And if you think of your homes, they're probably not very well insulated. They need much better insulation. There are grants available to get that better insulation. We're probably all using old-style lighting rather than modern energy efficient lighting and so on. So there's a lot of work could be done to improve on the energy usage in the home, and sensors can be used to do that. So if you take Ireland at the moment, there's about 1.5, 1.4 million houses in the country. We're using 40% of total energy in Ireland in houses, and 30% of the CO2 emissions are coming from those houses. And they're introducing EU directives in order to reduce the energy usage. Many of you may have had people calling to your homes to actually measure the energy quality of your homes. Now, the way to achieve better energy efficiency is actually to start using sensors in the home, so we could measure temperature in rooms, humidity, fresh air. We could measure occupancy. If people aren't in the rooms, there's no point in having the heating on and so on. There's no point in having the lights on. And the issue there is, if we wire the sensors in, they will cost a lot of money. However, if we use wireless sensors in a form like this, or in a form like the credit card, where they're already able to communicate with each other, then we can reduce the cost dramatically. And ultimately what you want to be able to do is go to a DIY store, and you want to be able to buy these sensors and install them yourselves. So they should be programmable by screwdriver. There's no point in me making fancy technology if you can't use it. And that's something that you need to think about as well if you're getting into science and engineering. It's not enough to be focused on how smart the technology is. You have to be able to make it useful. That's the delivery of the value. So we have a range of programs that we're working on, funded by Science Foundation Ireland, Enterprise Ireland, and so on. And we work with a range of companies, multinational companies and indigenous companies. And this is really important, to be working together across different institutes and universities in multidisciplinary programs, but working to take the technology out into industry. That's a critical thing. That's where the jobs are going to arise. Let's move on to environmental monitoring. There's a lot of interest in water quality monitoring, monitoring blue flag beaches throughout the country. Air quality monitoring is of interest. monitoring of landfill sites, is there pollution in those landfill sites, waste management.